In this video, we'll be finding domain and range from graphs. We're asked to give the domain and range of each relation. Now, our relation is a set of ordered pairs. In our first example, we can see that we have 4 ordered pairs. And our domain, we know, is the set of all the x's. So for this ordered pair, the x value is -2. For this ordered pair, the x value is also -2. We don't repeat set elements, so we'll just list -2 once as our domain element. We also have a domain element x equal 4 here and here, so we'll only list that once. So our domain is the set -2, 4. The range is the set of all the y values. So for these 2 points, we have 3 and 0. Let me list those in order. And then for these 2 points, we also have 3 and 0, so we're not going to repeat those. Our range then for this relation is the set 0, 3. Let's try another one. Now here we're not given any numbers, but we know that because the arrows are on the ends of this line, that my x values, I'm going to go to -infinity to the left and +infinity to the right. So my domain is the set from -infinity to +infinity. Now remember, when you use interval notation like this, and one of the endpoints is either -infinity or +infinity, you need to use a parentheses to show that this is not a specific number, that it's an open interval. Now for my range, since I'm going down to -infinity, this arrow is going down, and up to +infinity, the range is also an open interval from -infinity to +infinity. For this relation, we have an ellipse, and it looks like the x value that we use furthest to the left is -5. The x value to the right is +5. And since this is a continuous line, we can't show specific points. We need to indicate our domain with an interval notation. -5 is included as the left bound, and +5 is included as the right bound. So this will be a closed interval from -5 to +5. So this shows all numbers in between and including -5 and 5. Our range, the lowest y value is -3, and the greatest y value is +3. So this one is a closed interval from -3 to +3 inclusive. And make sure you write your intervals in order of the way the numbers occur on the number line. So you need to have the smallest or the least value on the left, and then the greatest value on the right. For this relation, we have a parabola that opens down. Our domain, we need the x values, and because I have an arrow here on this end of the parabola, that means I'm going on and on forever to the left. So negative infinity is going to be my left bound, and that has to be an open boundary. And then on the right, again, I have this arrow showing that it goes forever and ever to the right. So I have a positive infinity as my right boundary, and it's open. For the range, my lowest y value, I have the arrow that goes down forever and ever. So it's going to be a negative infinity as my left boundary. And my y that's the greatest is going to be the y coordinate for this point right here at the vertex. And we can see that that's 4. The 4 is included, so my upper bound is 4, and it is included in that set.